Good day everyone, myself Tripti Mishra. I welcome you all on my YouTube channel Ncert Science. Today we will discuss class 9th chapter 1 Matter in our surroundings. Already we have discussed 4 parts of this chapter. Today it is part 5. As in our earlier videos, we have discussed that if we increase the temperature and give the heat to the matter, then the liquid matter changes to the vapor. But do we always need to heat or change the pressure for changing the state of matter? We have some examples in our everyday life where change of the state from liquid to vapor takes place without the liquid reaching the boiling point. Water, when we left uncovered, slowly changes into vapor. Wet cloths dry up. Then what happens to water in the above two examples? We know that particles of matter are always moving and never are at rest. At a given temperature in any gas, liquid or solid, there are particles with different amount of energy. So, they have the different amount of energy. Particles have different amount of energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy. Those particles who are at the surface, they have more kinetic energy and they are able to break away the force of attraction of other particles and get converted into vapor. This phenomena to change of a liquid into vapor at any temperature below its boiling point is called evaporation. So it is different from the boiling. Only the surface particles are getting the energy from the surrounding and they are get free from the attraction force and convert to the vapor. So the phenomena of change of liquid into vapor at any temperature below its boiling point is called evaporation. Here we will discuss factors affecting evaporation. First factor is increase of surface area. As we know that evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting cloths for drying up, we spread them out. You have seen to your mothers also. Now, so as we will increase the surface area, evaporation will be increased. Next, the factor which affect the evaporation is the temperature. Increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. So, as the temperature is increased, evaporation is increased. Next point is humidity. Next factor which affect the evaporation is humidity. Humidity is the amount of water vapor present in the air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. It means if the humidity is more, then rate of evaporation decreases. If humidity is less, then rate of evaporation increases. During the summers, humidity is less, so rate of evaporation is more. During the rainy season, humidity is more, so the evaporation is less. Next factor affecting the evaporation is wind speed. It is common observation that cloths dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind decreases the amount of water vapor in the surrounding. So we can say the higher the wind speed, more evaporation, and lower the wind speed means less evaporation. So these were all the factors affecting evaporation, and you can feel them in our everyday life. In an open vessel, the liquids keep on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings make the surrounding cold. What happens when you pour some acetone or nail polish remover on your palm? The particles gain energy from your palm or surrounding and evaporate, causing the palm to feel cool. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Can you cite some more example from the daily life where we can feel the effect of cooling due to evaporation? Yes, people wear cotton cloths in summer season. Here is also the effect of cooling due to evaporation. During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of the liquid gain energy from the surroundings or body surface and changes into vapor. The vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. So here we can say that particles of liquids absorb energy from the surrounding to regain the energy loss during evaporation, and this absorption of energy from the surrounding causes cooling. So this we can say evaporation causes cooling. Now we will compare evaporation and boiling. So here it is the topic evaporation versus boiling. Sometimes in the exams that is asked difference between evaporation and boiling. So boiling is a bulk phenomena. We have already studied that boiling is a bulk phenomena. Particles from the bulk whole of the liquid changes into vapor state. So boiling is a bulk phenomena. Instead of boiling, evaporation is a surface phenomena. Means only the surface particles are involved in evaporation. Particles from the surface gain enough energy to overcome the force of attraction in the liquid and change into the vapor state, that is evaporation. So main difference is evaporation is bulk phenomena and evaporation is surface phenomena and boiling is bulk phenomena. And boiling occurs at the boiling temperature and evaporation occurs below the boiling temperature. As we have studied earlier, three states of matter that were solid, liquid and gas. But now scientists are talking of 5 states of matter. They also includes 2 other states that are plasma and Bose Einstein condensate. So already we have covered in the earlier video solid, liquid and gas. So in this video we will cover plasma and Bose Einstein condensate. Now we will study the fourth state of matter, that is plasma. The state plasma consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tube and neon sign bulbs consist of plasma. Inside a neon sign bulb, there is a neon gas, and inside a fluorescent tube, there is helium gas or some other gas. The gas get ionized, that is get charged when electrical energy flows through it. It means a plasma is a very good conductor of electricity and is affected by the magnetic field. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of gas. The sun, the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature. So, we can say that this state consists super energetic, super excited particles, ionized gas, and it is a good conductor of electricity, and plasma like gases have an indefinite shape and indefinite volume. It is ionized gas. Before going to the fifth state of matter, we should also know about the two great scientists, that is S.N. Bose and Albert Einstein. In 1920, Indian physicist Satyendranath Bose, S.N. Bose, had done some calculations for a fifth state of matter. Building off his calculations, Albert Einstein predicted a new state of matter, the Bose Einstein condensate, or in short which we call BEC. So that the main contribution in fifth state of matter BEC was of the S.N. Bose and Albert Einstein. In 2001, Eric A. Cornell, Wolfgang Ketterle and Carl E. Wieman of USA received the Nobel Prize in Physics for achieving Bose-Einstein condensation. The BEC is formed by cooling a gas of extremely low density, about 100,000 the density of normal air, to super low temperature. So, a BEC or Bose-Einstein condensate is a state of matter that can arise at low temperature, and that scientist who discovered this BEC, they got the Nobel Prize. The BEC is all about the molecules that are really close to each other, even closer than atoms in a solid, so their density is very low. Now we will study about the microscopic explanation for properties of plasma and Bose-Einstein condensate. First we will study about plasma. Plasmas have a definite shape and an indefinite shape and indefinite volume, because the particles can move past one another. Plasma are easily compressible because there is a great deal of free space between particles. Plasmas are good conductor of electricity, are affected by magnetic fields because they are composed of ions. So they are composed of ions. So main things is they have indefinite shape, indefinite volume, easily compressible, and good conductor of electricity, and they are composed of ions. Now, microscopic explanation of for properties of BEC, Bose Einstein condensate. Particles are less energetic. In this state, particles are less energetic than solids because exist at very low temperature. They are also exist in very low temperature. Particles are literally indistinguishable because they are locked into the same space. So they are indistinguishable. And BEC shows superfluidity because particles can flow without friction. So that is the microscopic explanation for plasma and BEC. So friend, like this video, share the video with your other friends, and most important, subscribe my YouTube channel. Also, I will provide you the other links of my earlier videos in the description box. Also press the bell icon so that you will get the notification as I will upload my next video. Thank you.